So now we're going to look at, let's say my function is f of t dt, and I'm going to look at a definite integral here where it's going to start off at a, but now it's going to go up to a variable x. So again, remember that this represents the area under the function y equals f of t from t equals a to t equals x. So once I put in a value for x, I would get back the area. So this is really like a function of x. I'll call it capital F of x. And so what I want to know is for this function, f of x, I'll ask the following question. What is the derivative of this function? Well, let's look at an example. It's kind of a hard question maybe to ask in general. So let's look at this example here. First, we're going to find the function. So let's evaluate the function f of x. It's going to be the integral from 0 to x cosine t dt at some values. Let's go for x equals 0, pi over 4, and pi over 2. So we're going to use the fundamental theorem of calculus, 0 to x, cosine t dt. So what function has derivative cosine t? It's sine t. So this becomes sine of x minus sine of 0. Well, sine of 0 is 0, so this is just sine x. So it appears that our function capital F is sine of x. And so now we can plug in our values. I wanted f of 0, sine of 0 is 0, f of pi over 4, sine of pi over 4 is square root of 2 over 2, and finally f of pi over 2 is 1. But really, now I want us to look at this function and find its derivative. F of x is sine x, so what's the derivative of sine x? It's going to be cosine x. So, what did we just find out? The derivative of f of x, but remember this was the, f of x was that definite integral, 0 to x, cosine t dt. It's just going to be cosine of x. And remember that derivatives and integrals, they're kind of like opposite operations of each other. And so you might ask, does this always happen? Do I just replace t by this x here? And the answer can be found in what's called the second fundamental theorem of calculus. So I'll state it here. It says if f is continuous on an open interval I containing a, then for every x in the interval, the derivative of the integral from a to x will be f of x. So as long as your bounds have a constant on the bottom here in a, and the upper bound is x, then the answer is yes. You just plug in x into the function.